In this problem, we are given a table of values of the first derivative and second derivative of a continuous function fx on some intervals as well as some points. For part A, we need to check whether the points -5 and -2 are the local maxima or minima. First of all, these points are the critical points because the first derivative is 0 over here. At -5, we can't use the first derivative test because we are not sure about the sign on this interval on the left of -5. So we have to move to second derivative test, and the second derivative test says if the value of second derivative at that critical point is negative, then the critical point would be local maxima. Next, we check the point -2. At -2, we see that the derivative changes sign from negative to positive. That means this is a local minima because whenever the derivative changes sign from negative to positive, it is a relative minimum, and when the derivative changes sign from positive to negative, it is relative maxima. So the point -2 is local minimum. For second part, we need to find some additional values where this function can have local maxima or minima. So let us look for critical points first. Apart from -5 and -2, the critical points are 3 and 13. We know that critical points are those where the first derivative either does not exist or 0. So these two are the critical points 3 and 13. We can't say anything about 3 because we are not sure which sign is there on the right side of 3. We are not sure about the sign of derivative on the right side of 3. First derivative test cannot be used here, and the second derivative as well, because the second derivative also does not exist here. So we can't say anything about 3. Let us look at 13. Since it is not an interval, we are not given intervals on the left and the right of this point, so we have to use the second derivative test. We see that second derivative is positive at 13, so this would be a local minimum. For next part, we need to find the points of inflection for the given function. We know that points of inflection are those where the second derivative changes from positive to negative or negative to positive. Before moving forward, we should know what are the possible points of inflection. The possible points of inflection are those where either the second derivative is 0 or it does not exist. We have three candidates for the possible points of inflection here: -2, 3 and 11. Let us look at -2. Here the second derivative changes sign from negative to positive. That means it was concave down on the left and concave up on the right. So it is changing its concavity from negative to positive. So this is a point of inflection. Let us look at 3. Here the second derivative is changing sign from positive to negative. That means concavity is changing at this point. So this is also a point of inflection. Now let us look at 11. The function is concave down on the left of 11, but we are not sure on the right side of 11. But we are not sure whether the second derivative is positive or negative or in the immediate neighborhood of 11. So we can't say anything about 11. So this cannot be the point of inflection for the given function. For the last part, we need to check the line tangent to the graph of fx at x equals 6 is used to approximate the value f of 10. Will this approximation be an over or underestimate of f of 10? Whenever we need to check the underestimation or overestimation using the tangent line, we check the concavity. Whenever a function is concave down, and then the tangent line on this function always gives an overestimate. And when the function is concave up, then the tangent line always gives you an underestimation. We need to check the value of second derivative at 6. 6 lie on this interval between 3 to 11, and the second derivative is negative on this interval. That means this is going to be concave down on this interval. So this is the case. When the function is concave down, then the tangent line always gives you an overestimation. So f of 10 would be overestimation.